Okay, so here's a function that we'll talk about a bit in calculus because it makes a point for us. It's the absolute value function. And because I know that you know what it looks like, I'm going to get you to graph it right here. Could you graph y equals absolute value of x? So there it is. The question is, where is this function differentiable? Well, our absolute value function is in fact piecewise defined. It's equal to x when x is bigger than equal to 0. It's equal to the negative of x when x is less than 0. So the problem comes in, what happens at 0? What's its derivative? Okay, so what is f prime at x? It is the limit as h approaches 0 of the function at x plus h minus the function at x all over h. And here's the problem, is that this function, absolute value x, is piecewise defined. And it changes definition at 0. So what happens if we let h approach 0 from the right-hand side? So if I'm approaching 0 from the right-hand side, I'm using this rule for my absolute value function. So then what's the absolute value of x plus h? Well, I'm always choosing a number a little bit bigger than 0. Then I've got x plus h minus absolute value of x. If x is greater than 0, it's just x all over h. This is limit as h approaches 0 from the right. So what is that? We get h over h, 1. And I think you already knew that. What's the slope of the tangent line to the curve? Well, it's always 1 if x is greater than 0. What about if we look at the left-hand side? That is, what's the limit as h approaches 0 from the left for this function? Well, if I'm approaching 0 from the left, I'm choosing x values below 0, so then I have to take the negative of it. So this would be limit as h approaches 0 from the left of the negative of x plus h minus the negative of x all over h. And once again, watch your signs. We got a subtraction of x and a adding of x. The x's are going to cancel. What h do I get on top? A negative h over h. And the left-hand limit then is negative 1. So, of course it is. What's the slope of the tangent line to the curve at any point less than 0? That slope is negative 1. So this is what our f prime looks like. Here is f prime at x. If f at x equals absolute value of x, f prime at x looks like this. Here's a y value of 1. As long as x is greater than 0, our derivative is 1. When x is less than 0, our derivative is negative 1. The question is, what's f prime at 0? What's f prime at 0? Does the left-hand limit equal the right-hand limit? No. So at 0, the limit doesn't exist. So f prime at 0 does not exist. You can't take the derivative. Okay, so back to an intuitive picture of what a derivative is. It's a slope of a tangent line to a curve at any point, and that tangent has to be unique. If we go to a corner like this, do you see that we could draw infinitely many tangent lines, actually? We don't have a unique one. So we don't have a tangent line to the curve at that point. We'll get into that in the next chapter. We'll talk about when is a function differentiable, and we'll find that it needs to be a smooth curve. Okay, so you guys got lots of fun homework for the weekend.